alkylation and Friedel-Crafts acylation. So first Friedel-Crafts alkylation. Friedel-Crafts alkylation. In this reaction, Friedel-Crafts alkylation, we are going to do the substitution of alkyl group on the benzene ring. So for this purpose, benzene reacts with alkyl halide. Benzene reacts with the alkyl halide in the presence of Lewis acid. Lewis acid is the catalyst. So here AlCl3 is Lewis acid, and which is acting as a catalyst to give that alkyl substituted benzene. For example, here you can see that okay. So this is the benzene, and this is the, what is the name of this? What is the name? Can anybody tell what is the name of this? There is chlorine here. What is the name of this? Toluene. It is the or methyl benzene. Toluene or methyl benzene. Okay. So this is the Friedel-Crafts alkylation. It is the Friedel-Crafts alkylation. So here methyl chloride is there. What is the product? Methyl benzene is the product. Methyl chloride is reacting with the benzene in the presence of AlCl3 to give the methyl benzene. Now you take benzene and reacts with ethyl chloride. It is the ethyl chloride, and in the presence of AlCl3, what is the product? Can you guess what is the product? What is the product here? What is the product here? Ethyl benzene. Okay. So this is ethyl benzene. Okay. Next, benzene reacts with propyl chloride. What is that? Benzene reacts with propyl chloride. What is the product? NEET students, what is the product where benzene reacts with the propyl chloride? What is the product? What is the product? Isopropyl benzene. What is the product? Isopropyl benzene. Why not propyl benzene? Why it's given that isopropyl benzene as the major product? Can you guess it? What is the stability? What is the stability of What is the which is getting the stabilization here? Look at the mechanism. Look at the mechanism. First, what happens? This propyl chloride reacts with AlCl3. Propyl chloride reacts with what? CH3, CH2, CH2, Cl plus AlCl3. AlCl3. What happens? This is the Lewis acid. What is meant by Lewis acid? Lewis acid is the electron deficient. Lewis acid is the electron deficient, and this will be taking the AlCl3 with electrons, and it forms as a CH3, CH2, CH2 plus or minus. CH3, CH2, CH2 plus or minus. Plus. Right? And you are going to get that AlCl4 minus. Right? Now, here what happens? Here what happens? Two hydrogens are there now. Now this is the cation. Right or not? The positive charge is present on the carbon, so it is the carbocation. It is the carbocation. Right? And can you guess whether it is the primary carbocation or secondary carbocation or tertiary carbocation? Can you guess it? Tell me, what is that? Primary or secondary or tertiary? Primary carbocation. For example, this is the primary carbocation. This is the primary carbocation. This hydrogen is shifting to this carbon. This hydrogen is shifting to this carbon. What you are going to get it? What you are going to get it? CH3, CH, CH3, and here you are going to get the positive charge or positive charge. Tell me, this is the primary cation, and what about this? Secondary carbocation. Alright? Secondary carbocation. Go for the stability order of the carbocations. What is the stability order of carbocations? Stability order of carbocations. Tertiary carbocation is more stable, secondary carbocation, then primary carbocation. Understand? So, now you have that primary and secondary carbocation, which is more stable, that will form more easily. Which is the most stable carbocation that forms more easily. So, here compared to primary carbocation, secondary carbocation is more stable. So, it is more favorably forms. Okay. So, after forming the secondary carbocation, next what happens here? Next we say, you have benzene ring, right? Benzene ring you have, and you have electrophile also. You have electrophile. Now what happens? You know the mechanism. In the previous class we discussed about the mechanism, how it forms. So this reacts, the pi electrons, it moves to this carbon, and this this electrophile can attach to the benzene ring to give that isopropyl benzene. It is the cumin. Understood? All of you understood? Any doubt? Okay. All of you noting down? Finished or not? Okay, next what happens when benzene reacts with n-butyl chloride, CH3 CH2 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 Cl AlCl3. What is the product it forms? Can you guess it? What is the product possibility is there? What is the product possibility is there? Check the mechanism. Which is the stable carbocation here? You check it. CH3 CH2 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 Cl reacts with AlCl3 to provide that CH3 CH2 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 plus AlCl4 minus. This is the primary carbocation. Is there any chance to form the secondary carbocation? Is there any chance to form the secondary carbocation? Yes, there is a chance to form the secondary carbocation. How it can form the secondary carbocation? Check it here. One hydrogen can shift from this carbon to this carbon to bring what? CH3 CH2 CH3. This is the primary carbocation and this is the secondary carbocation. Okay. Now which reacts with the benzene? Either primary carbocation or secondary carbocation? Secondary carbocation. It reacts with the benzene. So what is the major product in here? CH3 CH2 CH3. Positive charge is here. Then the pi electrons moves to that carbon and it forms that. What is the product? What is the product it forms here? CH3 CH2 CH3. What is the name of this? Secondary butyl